Hello and welcome to Visit's introductory course on social science. This is a basic level course that's designed for those that don't know very much about social science. It's meant to provide just a brief glimpse into what makes social science a science. But to fully understand the topic, of course, you'd have to attend one or more full semester freshman level courses in college. Still, even if you feel like you know a lot of these basics, please hang with us. There's still stuff to learn. The goals of this course are pretty simple. First, we want to provide physical scientists with a little insight as to how social scientists do their work. That is, how do they go about studying people and populations? Second, we want to compare the principles and methods used by physical scientists versus those used by social scientists, including the differing focus variables, data collection methods, different data analysis techniques, and so on. Visit is currently working on a course that discusses designing effective surveys. The present course is designed to provide an overview of the principles upon which that course will rest. So what is social science? What is social science? Basically, social science is concerned with understanding individual and societal behaviors. There are a lot of subdisciplines within the broad category, and most of them constitute separate university degree programs, as I mentioned. I've listed a few here that you can have direct application to our work. Communications, of course, is one of our biggest missions or problems, if you will. Psychology for us just involves understanding how people react to messaging and to natural emergencies. That's kind of a biggie as well. In our case, anthropology most often means things like dealing with different cultural groups. And for our purposes, sociology involves institutional characteristics and behaviors. Think about groups like firefighters, police, emergency managers, school officials, and so forth. And of course, economics just means managing infrastructure and cost balancing and whatnot. So, communications, that's always been one of our biggies. The problems we find in communications exemplify the complexities of individual and societal behaviors in general. So, consider these factors, which always need to be addressed when we're communicating. Does your target audience hear your message? That's the first. Who are the people you're trying to reach? Where are they? Think about emergency responders, public officials, individuals, the media, and so on. Every group is going to react differently, plus there's a wide range of behaviors and attitudes within every societal group. Even if you've gotten a solid communications channel open, you'd like to know whether your target audience understands your method, whether you understand them. That's really an important factor. We'll talk about that in a minute. And maybe the toughest of all, do they even care? So let's look at each one of these in a little more detail as a social scientist might look at them. First of all, what is your intended audience doing, and will they even hear your message? People are seldom in a single location through the day. How do we reach people, say, at work or at home or in their cars or shopping or maybe in a bar or picking up kids or whatever? The question here is, where are the people we want to reach, and how do we reach them there? This is a problem that's just made for social science. Then you got to ask, does your intended audience understand you? What's their knowledge base? Do they understand the event you're warning on? Maybe they have problems with your terminology or your language. Do they completely understand the nature of the threat? Do they understand how to respond if they do? Even if they believe you, do they know how to understand how to respond? NWS programs like Storm Ready are invaluable in this regard. But it's a two-way street. How do they think about your topic? How do they react? How have they reacted in the past? Why did they react that way? Again, a social science problem. Do you have a preconceived idea about what their reaction is going to be? You may think you know why people react the way they do, but can you prove it? We must never assume. This is an important statement down here, that because we've seen people react the way they have in the past, we understand their motivation and know how they'll react in the future. This simple fact is particularly true when it comes to population groups. Finally, does your audience even care about your method? This is one that's bothered me a long time. I've worked in severe weather most of my meteorological life, and severe weather, and I have always been concerned about this problem. Do they care about the message? Uh, Previous experiences can make a big difference. Maybe they've experienced a lot of false alarms in the past, or maybe they've experienced the very events you're warning about and have never had a problem dealing with them. They may just blow us off. Remember that the personal priorities can play a role too. This category might include things like getting to work, or picking up the kids, or personal commitments that place your message very low on their priority list. Uh, Social factors, I've mentioned a few of these. Let me describe what I've listed here. And there are many others, but groupthink is a biggie. Groupthink can happen in any social group that has a common goal and strong leadership. Think about a situation maybe where there's a warning issued for an intense winter storm, but maybe a sales team has scheduled an important meeting downtown. It may be already snowing pretty hard, but when people talk about not coming in, or call in about not coming in, the boss may pressure the whole team to come in anyway, emphasizing the importance of the team goals. Maybe you're worried, push doubts aside, and decide to drive in anyway. Groupthink is when team needs override even personal safety. The bandwagon effect is a little bit different. It comes about when people observe group behavior and make decisions based on the majority. In the example of the snowstorm here, this might be maybe you go turn on the TV and seeing the crowded highways, deciding that it must be okay because everyone else is doing it. Illusion of control and overconfidence. Here a person might believe that they've driven in winter weather many times before and they can handle whatever comes up. Or think about tornado chasers who get in a little bit too close, thinking that they've done it all before. They understand severe storms, and so they think they can handle whatever comes up. That's overconfidence and also illusion of control. And the last little example here is status quo. People have a tendency to think that the extreme possibility is unlikely. They make themselves believe that everything's going to be all right. All of these are factors when you're communicating with the public that have to be considered, and social scientists know how to go about studying those particular aspects of the problem. So I'm going to begin the discussion of why social science is a science by comparing the two sciences. We'll begin to we'll look at social science versus atmospheric science as our physical benchmark because we're atmospheric scientists, but the principles hold true for most physical sciences. Okay, so here I'm going to define the term focused variables, by the way, to mean the variables that are of interest for each of our sciences, that is our data. For atmospheric sciences, focused variables include things like temperature, dew point, pressure, wind speeds, and so forth. Our goal is to model and predict future atmospheric behavior. Social sciences, on the other hand, they attempt to quantify various aspects of human behavior through either available measures that have appeared in the literature, through observations or surveys, or even experiments. I'm going to pause here a second and look a little more closely at the focused variables for the social sciences, since they're not as familiar to us as the other. We're going to talk about individual behaviors, individuals within groups, and group dynamics. When we talk about individual behaviors and traits, we're actually talking about how people's traits and personalities affect how they'll react in various situations. And these traits, they include things like agreeability, resilience, this is real big right now, their intelligence, their decisiveness, their personality, and so forth. There are a lot of pre-established tests available for individual traits based on refereed literature, and social scientists know about these and try to use them when they can. The effects of individual behaviors within groups are pretty much often overlooked. I think a lot of times they're overlooked. For example, every group has its own identity and includes its own demographic variables. Think about families. If you're with your family, or different cultures, how different cultures might react to different messaging. Socioeconomic status, age, gender. These all can significantly affect how a person deals with a situation. This also means that an individual's reaction may be different in the same situation depending on the group they're associating with at the time, which is a scary kind of a thing to think about. But finally, consider group and institutional dynamics, something we've probably all dealt with. Institutional groups generally have their own unique characteristics, belief, behaviors, etc., expectations, procedures. Familiar examples might include groups like police officers, firefighters, school officials, and even National Weather Service forecasters. Think about your own group and how you think about different missions and situations. Okay, so continuing on with our contrast between the physical and social sciences, both the physical and social sciences require data, but observation and data collection methods can differ appreciably. In atmospheric sciences, as you know, we use mostly direct measurements, things like thermometers, hygrometers, barometers. Physical sciences depend almost entirely on instrument-based observations. Social science uses mostly indirect measures. Humans, both individually and groups, represent one of the most complex and intricate systems on the planet. There are no equations to define humans yet. Social scientists primarily depend on field observations, surveys, case studies, established tests like I mentioned. And when we talk about field observations, by the way, in the social sciences, we're talking about observation of behavior in controlled environments. Think candid camera or something like that. I should note that there are a few direct measures in psychology, things like MRIs, biofeedback techniques, but in the overwhelming majority of instances, people's behaviors are not directly measurable. When it's time for data analysis, the approach is often very different. For atmospheric science, analysis depends heavily on the so-called governing equations. As most of us know, these equations are based on the principles of physics and are expressed in differential equations, integral equations, vectors, and so on. Also, some atmospheric scientists depend on statistical and parameterization techniques, people like climatologists or modelers. But when it comes to the social sciences, there are no governing equations. As I said, human processes are usually far more chaotic than most physical processes, and there are far more degrees of freedom in human behavior, which is the biggest factor. Still, there's some hope. It turns out that many of the processes associated with human populations are normally distributed or close to it. That's why scientific studies in social science almost always rely on statistical techniques. Social science researchers are usually very good with statistics. I recently went back for a degree in psychology, a second degree in psychology, and found out that most of the researchers in that field are very good at statistics. The majority of the scientists researching, doing statistical research in that end of things, have the equivalent of anything from a bachelor's to an upper level degree in statistics. Anyway, a couple of words about error sources. First, we know that all scientists try to design experiments that have solid conclusions and reproducible results. That's science. Measurements are crucial, but there are errors both in the physical and social sciences. Both sides of the aisle have many processes that are not fully understood. Human science, of course, is pretty far out on that variable, but we too have a lot of processes that aren't fully understood, and we require assumptions and approximations and so forth. Both of us have trouble with collecting representative data, and we both have inherent errors in the actual measurements. So the representative data, as we all know, limited number of soundings, limited number of surface sites trying to make implications about the future, trying to extrapolate data onto a small-scale grid. All of this is a problem for us. Representative data, we'll talk about that a little bit here, but then in the next course on designing a survey, we're going to talk about that a lot. Just as a note, there's generally two broad categories of statistically based social science research. One is descriptive, the other is experimental. Descriptive research includes things like natural observations, interviews, surveys, the things we're kind of familiar with. The pros on that is that they're the least complex and they're fairly easy to design and carry out. Also, gaining institutional review board approval is fairly straightforward on that sort of thing. The cons are that natural observations are often difficult to quantify. Properly designed questionnaires can be quantified, but they can only establish correlation and not causation. That's an important thing to remember when you're doing a survey. Sometimes this type of study, though, does provide insight, and they're good for overviews, too, and for quick looks or pilot studies. Experimental research actually manipulates subject groups. Questions are designed to divide groups into experimental versus control groups, manipulating different experiences. An example might be something like phrasing a question in a positive or negative way on different versions of the survey, or maybe substituting completely different questions in one or two different questions in one survey versus another to test the differences in people's opinions. The pros on this is it's designed to uncover cause and effect. You can design it. It's very difficult to carry out this kind of a design. The cons, the development process for a single experimental study can take months. You're clarifying questions, assuring that the manipulation is ethical, trying to remove ambiguities, fitting your work into previous research, and so forth. And the institutional review board approval for one of these type experiments is very, very difficult. So we're not going to be going there. As noted earlier, Visit is currently in the process of designing a short course on effective survey design. So for the last part of this session, I'm going to preview a few things that will be handled in more detail in that course. Let's take a brief look. Most social research involves questions, especially descriptive studies. Usable results depend on careful survey design, where there's many things to consider. There's numerous human biases that you've got to account for when you're making your questions. Got to format the question set properly. That's critical to later analysis. And finally, design questions with statistical analysis in mind. The biases we're going to talk about in much more detail in the survey course include things like sampling bias, that is, who are we talking to? This goes back to the question of representative sampling. If we're talking to a group of students versus a group of seniors versus a group of daytime shoppers, we're probably going to get different results to the same survey. And if we are trying to make a survey that's representative of the general population, we've got to take factors like sampling bias into account. There's also a thing called self-reporting bias and volunteer bias. Self-reporting, are the answers true? Only the participants know for sure. Maybe they answer with personal image in mind. Maybe they have memory problems. Maybe they have emotional responses to the way you phrase the question. Maybe they're doing playful sabotage. I've had that happen to me in the past. Maybe they're having trouble understanding the question. And anyway, volunteer bias means you're only getting answers from people who want to answer a survey. Cultural bias, different cultures think about the same thing differently. Participant bias, there's a sociability problem in participant bias in that people don't want to come off looking bad. Should street drugs be legal versus does making street drugs illegal always help contain associated problems? We will be getting into those kind of questions. So I won't spend any more time on the biases here, but stay tuned for our course on building an effective survey. Another thing with survey design is formatting your questions. Your questions must always focus on the study's goal. That's key. Questions have to be formatted to answer that specific question or questions. Questions should be designed with analysis in mind, as I mentioned. And you also need to use language that your participants will clearly understand. Psychological research shows that short and concise questions people tend to respond more carefully and truthfully than longer questions. And of course, things like loaded questions, how often do you ignore those irritating weather warnings, are out. Leading questions too, they're out. Should responsible people heed weather warnings to safeguard their family? That kind of a question. You know the answer you want, and you're crafting your question to get the answer you want. That's a big no-no. A few more vague questions. Do you attend church regularly? What's regularly? Limiting the options to have the survey come out the way you want. We'll be talking about that. Double-barreled questions don't give you any answers. Don't give you answers that you can run statistics on. And the last one here is really a pretty interesting finding in this study. In that the order that questions are asked can actually affect the outcome. In this particular study, one question asked about people's satisfaction with their housing situation, and then questions in other parts of the survey asked about the presence or absence of amenities in their particular situation. And they found out that if the amenity questions were asked before the question on overall satisfaction, the overall satisfaction was lower than if the specific questions were asked later than the overall satisfaction question. So again, question order is important. And that study, by the way, was an experimental study because they had two different versions of it to test the two different orders. Okay, make a statistical plan as part of the original design, and that will make your study easier to analyze when it's done. You want to kind of design your questions realizing what type of measures you'll be using. You want to design quantifiable questions and comparable questions. You want to have either yes-no questions or equal number of multiple choices on Likert scaling. Likert scaling means don't like it at all, like it a little, neutral, like it a lot. Those are Likert kind of questions, comparative questions. If you're going to have those kind of questions in the survey, make sure that they all have the same number of choices because it makes the statistics a lot easier to do. And if you're going to have some open-ended questions, make sure that you know how you're going to handle them when your results come in and you get either short sentences or long paragraphs. Try to anticipate what kind of answers you're going to get and figure out how you're going to handle them in advance. Anyway, so final points. Remember the many parallels we've pointed out between physical and social sciences. Both are looking at complex problems that are not fully understood. Both use the scientific method as best they can, including controlled observations and mathematical analysis, to the extent that they can, with social science being under a little bit worse situation due to the complexity of human individuals and populations. Also remember the many parallels between the two in terms of errors. We all have errors. We all have non-representative observations, confounding variables, making necessary approximations and parameterizations. Finally, remember that both sciences, I want to reiterate this, both sciences try to utilize the scientific method to the best of their ability. Both depend on rigorous adherence to the scientific method, namely make a hypothesis, test it, and either accept or reject it. And finally, I want to emphasize that social science can help physical scientists carry out the parts of their job that deal with individuals, groups, and members' organizations. So now there's a lot more to it. This course has been an extremely brief overview, as I said. Its goals. If you're interested in following up a course, we'd suggest an introductory college-level course on research methods, and whatnot. And remember that Visit will be having no prediction on the date it'll be ready, but we will be having available a course on how to design an effective, simple survey for a lot of the questions you need to answer as forecasters.